Rainwater harvesting is the accumulation and storage of rainwater for reuse on-site, rather than allowing it to run off. Rainwater can be collected from rivers or roofs, and in many places, the water collected is redirected to a deep pit well, shaft, or borehole, a reservoir with percolation, or collected from dew or fog with nets or other tools. Its uses include water for gardens, livestock, irrigation, domestic use with proper treatment, indoor heating for houses, etc. The harvested water can also be used as drinking water, longer-term storage, and for other purposes such as groundwater recharge. Rainwater harvesting is one of the simplest and oldest methods of self-supply of water for households, usually financed by the user. History of rainwater harvesting. The construction and use of cisterns to store rainwater can be traced back to the Neolithic age, when waterproof lime plaster cisterns were built in the floors of houses in village locations of the Levant, a large area in Southwest Asia, south of the Taurus Mountains, bound by the Mediterranean Sea in the west, the Arabian Desert in the south, and Mesopotamia in the east. By the late 4000 BC, cisterns were essential elements of emerging water management techniques used in dry land farming. Many ancient cisterns have been discovered in Jerusalem and the entire land of Israel. At the site believed by some to be that of the biblical city of Ai, Khirbet et Tel, a large cistern dating back to around 2500 BC was discovered that had a capacity of nearly 1,700 cubic meters, 60,000 cu feet. It was carved out of solid rock, lined with large stones, and sealed with clay to keep from leaking. The Greek island of Crete is also known for its use of large cisterns for rainwater collection and storage during the Minoan period from 2600 BC 1100 BC. 4 large cisterns have been discovered at Myrtos Pyrgos, Archanes, and Zakroich. The cistern found at Myrtos Pyrgos was found to have a capacity of more than 80 cubic meters and date back to 1700 BC. Around 300 BCE, farming communities in Baluchistan, now located in Pakistan, Afghanistan, and Iran, and Kutch, India, used rainwater harvesting for agriculture and many other uses. Rainwater harvesting was done by Chola kings. Rainwater from the Brihadiswarar temple, located in Balagunpathi Nagar, Thanjavur, India, was collected in Shivaganga tank. During the later Chola period, the Varanam tank was built 1011 to 1037 CE in the Cuddalore district of Tamil Nadu to store water for drinking and irrigation purposes. Varanam is a 16 km long tank with a storage capacity of 1,465,000,000 cu feet, 41,500,000 cubic meters. Rainwater harvesting was also common in the Roman Empire. While Roman aqueducts are well known, Roman cisterns were also commonly used and their construction expanded with the empire. For example, in Pompeii, rooftop water storage was common before the construction of the aqueduct in the 1st century BC. This history continued with the Byzantine Empire, for example the Basilica cistern in Istanbul. Though little known, for centuries the town of Venice depended on rainwater harvesting. The lagoon which surrounds Venice is brackish water, which is not suitable for drinking. The ancient inhabitants of Venice established a system of rainwater collection which was based on man-made insulated collection wells. Water percolated down the specially designed stone flooring, and was filtered by a layer of sand, then collected at the bottom of the well. Later, as Venice acquired territories on the mainland, it started to import water by boat from local rivers, but the wells remained in use, and were especially important in time of war when access to the mainland water could be blocked by an enemy. Current uses. Canada. A number of Canadians have started implementing rainwater harvesting systems for use in stormwater reduction, irrigation, laundry, and lavatory plumbing. Substantial reform to Canadian law since the mid-2000s has increased the use of this technology in agricultural, industrial, and residential use, but ambiguity remains amongst legislation in many provinces. Bylaws and local municipal codes often regulate rainwater harvesting. India. Tamil Nadu was the first state to make rainwater harvesting compulsory for every building to avoid groundwater depletion. The scheme was launched in 2001 and has been implemented in all rural areas of Tamil Nadu. Posters all over Tamil Nadu including rural areas create awareness about harvesting rainwater. TNGOVT site. It gave excellent results within 5 years, and slowly every state took it as a role model. Since its implementation, Chennai had a 50% rise in water level in 5 years and the water quality significantly improved. Karnataka, in Bangalore, adoption of rainwater harvesting is mandatory for every owner or the occupier of a building having the site area measuring 60 feet (18.3 meters) times 40 feet (12.2 meters) and above, and for newly constructed building measuring 30 feet (9.1 meters) times 40 feet (12.2 meters) and above dimensions. In this regard, Bangalore Water Supply and Sewerage Board has initiated and constructed Rain Water Harvesting Theme Park in the name of Sir M. Visvesvaraya in 1.2 acres (4,900 square meters) of land situated at Jayanagar, Bangalore. In this park, 26 different type of rainwater harvesting models are demonstrated along with the water conservation tips. The auditorium on the first floor is set up with a green air conditioning system and will be used to arrange the meeting and showing of a video clip about the rainwater harvesting to students and general public. An attempt has been made at the Department of Chemical Engineering, IISc, Bangalore to harvest rainwater using upper surface of a solar still, which was used for water distillation. In Rajasthan, rainwater harvesting has traditionally been practiced by the people of the Thar Desert. Many ancient water harvesting systems in Rajasthan have now been revived. Water harvesting systems are widely used in other areas of Rajasthan, as well, for example the Chauka system from the Jaipur district. Maharashtra, at present, in Pune, rainwater harvesting is compulsory for any new housing society to be registered. In Mumbai, Maharashtra, rainwater harvesting is being considered as a good solution to solve the water crisis. The Mumbai City Council is planning to make rainwater harvesting mandatory for large societies. Israel. The Southwest Center for the Study of Hospital and Healthcare Systems in cooperation with Rotary International is sponsoring a rainwater harvesting model program across the country. The first rainwater catchment system was installed at an elementary school in Lod, Israel. The project is looking to expand to Haifa in its third phase. The Southwest Center has also partnered with the Water Resources Action Project of Washington, D.C., which currently has rainwater harvesting projects in the West Bank. Rainwater harvesting systems are being installed in local schools for the purpose of educating schoolchildren about water conservation principles and bridging divides between people of different religious and ethnic backgrounds, all while addressing the water scarcity issue that the Middle East faces. New Zealand. Although New Zealand has plentiful rainfall in the west and south, for much of the country, rainwater harvesting is the normal practice for most rural housing and is encouraged by most councils. Sri Lanka. Rainwater harvesting has been a popular method of obtaining water for agriculture and for drinking purposes in rural homes. The legislation to promote rainwater harvesting was enacted through the Urban Development Authority Amendment Act, No. 36 of 2007. Lanka Rainwater Harvesting Forum is leading the Sri Lanka's initiative. South Africa. The South African Water Research Commission has supported research into rainwater harvesting. Reports on this research are available on their Knowledge Hub. Studies in arid, semi-arid, and humid regions have confirmed that techniques such as mulching, pitting, ridging, and modified run-on plots are effective for small-scale crop production. Hydrofracturing has regularly been used to improve the performance of water boreholes. From 1990 to 1992, 170 boreholes had been hydrofractured. United Kingdom. In the United Kingdom, water butts are often found in domestic gardens and on allotments to collect rainwater, which is then used to water the garden. However, the British government's Code for Sustainable Homes encouraged fitting large underground tanks to newly built homes to collect rainwater for flushing toilets, watering, and washing. Ideal designs had the potential to reduce demand on Maine's water supply by half. The code was revoked in 2015. Other countries. In China, Argentina, and Brazil, rooftop rainwater harvesting is being practiced for providing drinking water, domestic water, water for livestock, water for small irrigation, and a way to replenish groundwater levels. Gansu Province in China and semi-arid northeast Brazil have the largest rooftop rainwater harvesting projects going on. Thailand has the largest fraction of the population in the rural area relying on rainwater harvesting, currently around 40%. Rainwater harvesting was promoted heavily by the government in the 1980s. In the 1990s, after government funding for the collection tanks ran out, the private sector stepped in and provided several million tanks to private households, many of which continue to be used. This is one of the largest examples of self-supply of water worldwide. In Bermuda, the law requires all new construction to include rainwater harvesting adequate for the residents. The U.S. Virgin Islands has a similar law. In Senegal and Guinea-Bissau, the houses of the Diola people are frequently equipped with homebrew rainwater harvesters made from local, organic materials. In the Irrawaddy Delta of Myanmar, the groundwater is saline and communities rely on mud-lined rainwater ponds to meet their drinking water needs throughout the dry season. Some of these ponds are centuries old and are treated with great reverence and respect. In the United States, until 2009 in Colorado, water rights laws almost completely restricted rainwater harvesting. A property owner who captured rainwater was deemed to be stealing it from those who have rights to take water from the watershed. Now, residential well owners who meet certain criteria may obtain a permit to install a rooftop precipitation collection system SB 09-080. Up to 10 large-scale pilot studies may also be permitted HB 09-1129. The main factor in persuading the Colorado legislature to change the law was a 2007 study that found that in an average year, 97% of the precipitation that fell in Douglas County, in the southern suburbs of Denver, never reached a stream. It was used by plants or evaporated on the ground. Rainwater catchment is mandatory for new dwellings in Santa Fe, New Mexico. Texas offers a sales tax exemption on the purchase of rainwater harvesting equipment. Both Texas and Ohio allow the practice even for potable purposes. Oklahoma passed the Water for 2060 Act in 2012, to promote pilot projects for rainwater and greywater use among other water-saving techniques. In Beijing, some housing societies are now adding rainwater in their main water sources after proper treatment. In Ireland, Professor Michael McGinley established a project to design a rainwater harvesting prototype in the Biosystems Design Challenge module at University College Dublin. New approaches. Instead of using the roof for catchment, the rain saucer, which looks like an upside-down umbrella, collects rain straight from the sky. This decreases the potential for contamination and makes potable water for developing countries a potential application. Other applications of this freestanding rainwater collection approach are sustainable gardening and small plot farming. A Dutch invention called the Groasis waterbox is also useful for growing trees with harvested and stored dew and rainwater. Traditionally, stormwater management using detention basins served a single purpose. However, optimized real-time control lets this infrastructure double as a source of rainwater harvesting without compromising the existing detention capacity. This has been used in the EPA headquarters to evacuate stored water prior to storm events, thus reducing wet weather flow while ensuring water availability for later reuse. This has the benefit of increasing water quality released and decreasing the volume of water released during combined sewer overflow events. Generally, check dams are constructed across the streams to enhance the percolation of surface water into the subsoil strata. The water percolation in the water-impounded area of the check dams can be enhanced artificially manyfold by loosening the subsoil strata and overburden using ANFO explosives as used in open-cast mining. Thus, local aquifers can be recharged quickly using the available surface water fully for use in the dry season. non-traditional. In 1992, American artist Michael Jones McKean created an artwork in Omaha, Nebraska, at the Bemis Center for Contemporary Art that created a fully sustainable rainbow in the Omaha skyline. The project collected thousands of gallons of rainwater, storing the water in 6 daisy-chained 12,000 gallons tanks. The massive logistical undertaking, during its 5-month span, was one of the largest urban rainwater harvesting sites in the American Midwest. Rainwater harvesting by freshwater flooded forests. Rainwater harvesting is possible by growing freshwater flooded forests without losing the income from the used, submerged land. The main purpose of the rainwater harvesting is to use the locally available rainwater to meet water requirements throughout the year without the need of huge capital expenditure. This would facilitate the availability of uncontaminated water for domestic, industrial, and irrigation needs. Rainwater harvesting by solar power panels. Good quality water resource, closer to populated areas, is becoming scarce and costly for the consumers. In addition to solar and wind energy, rainwater is major renewable resource of any land. Vast area is being covered by solar PV panels every year in all parts of the world. Solar panels can also be used for harvesting most of the rain water falling on them, and drinking quality water, free from bacteria and suspended matter, can be generated by simple filtration and disinfection processes as rain water is very low in salinity. Exploitation of rainwater for value-added products like bottled drinking water, makes solar PV power plants profitable even in high rainfall, cloudy areas by the augmented income from value-added drinking water generation. Advantages. Rainwater harvesting provide the independent water supply during regional water restrictions, and in developed countries, is often used to supplement the main supply. It provides water when a drought occurs, can help mitigate flooding of low-lying areas, and reduces demand on wells, which may enable groundwater levels to be sustained. It also helps in the availability of potable water, as rainwater is substantially free of salinity and other salts. Applications of rainwater harvesting in urban water system provides a substantial benefit for both water supply and wastewater subsystems by reducing the need for clean water in water distribution systems, less generated stormwater in sewer systems, and a reduction in stormwater runoff polluting freshwater bodies. A large body of work has focused on the development of life cycle assessment and its costing methodologies to assess the level of environmental impacts and money that can be saved by implementing rainwater harvesting systems. Independent water supply. Rainwater harvesting provides an independent water supply during water restrictions. In areas where clean water is costly, or difficult to come by, rainwater harvesting is a critical source of clean water. In developed countries, rainwater is often harvested to be used as a supplemental source of water rather than a main source, but the harvesting of rainwater can also decrease a household's water costs or overall usage levels. Rainwater is safe to drink. Rainwater is also independent of salinity or pollutants found in groundwater, increasing the quantity of portable drinking water available when rainwater harvesting is utilized. Supplemental in drought. When drought occurs, rainwater harvested in past months can be used. If rain is unpredictable, the use of a rainwater harvesting system can be critical to capturing the rain when it does fall. Many countries, especially those with arid environments, use rainwater harvesting as a cheap and reliable source of clean water. To enhance irrigation in arid environments, ridges of soil are constructed to trap and prevent rainwater from running down hills and slopes. Even in periods of low rainfall, enough water is collected for crops to grow. Water can be collected from roofs, dams and ponds can be constructed to hold large quantities of rainwater so that even on days when little to no rainfall occurs, enough is available to irrigate crops. In addition, rainwater harvesting decreases the demand for water from wells, enabling groundwater levels to be further sustained rather than depleted. Life cycle assessment. Life cycle assessment is a methodology used to evaluate the environmental impacts of a system from cradle to grave of its lifetime. Devkota et al. Developed such a methodology for rainwater harvesting, and found that the building design, e.g., dimensions, and function, e.g., educational, residential, etc., play critical roles in the environmental performance of the system. The Economic and Environmental Analysis of Sanitation's Technologies (EEAST) model evaluates the greenhouse gas emissions and cost of such systems over the lifetime of a variety of building types. To address the functional parameters of rainwater harvesting systems, a new metric was developed, the demand-to-supply ratio (DS), identifying the ideal building design supply and function demand in regard to the environmental performance of rainwater harvesting for toilet flushing. With the idea that supply of rainwater not only saves the potable water, but also saves the stormwater entering the combined sewer network, thereby requiring treatment, the savings in environmental emissions were higher if the buildings are connected to a combined sewer network compared to separate one. System setup. Rainwater harvesting systems can range in complexity, from systems that can be installed with minimal skills, to automated systems that require advanced setup and installation. The basic rainwater harvesting system is more of a plumbing job than a technical job, as all the outlets from the building's terrace are connected through a pipe to an underground tank that stores water. Systems are ideally sized to meet the water demand throughout the dry season, since it must be big enough to support daily water consumption. Specifically, the rainfall capturing area such as a building roof must be large enough to maintain adequate flow of water. The water storage tank size should be large enough to contain the captured water. For low-tech systems, many low-tech methods are used to capture rainwater: rooftop systems, surface water capture and pumping the rainwater that has already soaked into the ground or captured in reservoirs and storing it in tanks cisterns. Before a rainwater harvesting system is built, use of digital tools is useful. For instance, to detect if a region has a high rainwater harvesting potential, rainwater harvesting GIS maps can be made using an online interactive tool, or, to estimate how much water is needed to fulfill a community's water needs, the Rain is Gain tool helps. Tools like these can save time and money before a commitment to build a system is undertaken, in addition to making the project sustainable and long-lasting. Applications of rainwater harvesting. Agriculture. Missions to 6 Caribbean countries have shown that the capture and storage of rainwater runoff for later use is able to significantly reduce the risk of losing some or all of the year's harvest because of soil or water scarcity. In addition, the risks associated with flooding and soil erosion during high rainfall seasons would decrease. Small farmers, especially those farming on hillsides, could benefit the most from rainwater harvesting because they are able to capture runoff and decrease the effects of soil erosion. Many countries, especially those with arid environments, use rainwater harvesting as a cheap and reliable source of clean water. To enhance irrigation in arid environments, ridges of soil are constructed to trap and prevent rainwater from running down hills and slopes. Even in periods of low rainfall, enough water is collected for crops to grow. Water can be collected from roofs, dams and ponds can be constructed to hold large quantities of rainwater so that even on days when little to no rainfall occurs, enough is available to irrigate crops. Domestic use. In China, Argentina, and Brazil, rooftop rainwater harvesting is used to provide drinking water, domestic water, water for livestock, water for small irrigation, and a way to replenish groundwater levels. Gansu Province in China and semi-arid northeast Brazil have the largest rooftop rainwater harvesting projects going on. About 40% of Thailand's rural population utilizes rainwater harvesting. Rainwater harvesting was promoted heavily by the government in the 1980s. In the 1990s, after government funding for the collection tanks ran out, the private sector stepped in and provided several million tanks to private households, many of which continue to be used today. This is one of the largest examples of self-supply of water worldwide. Rainwater harvesting is mandatory for new homes built in Santa Fe, New Mexico. Texas offers a sales tax exemption for the purchase of rainwater harvesting equipment. Both Texas and Ohio allow rainwater harvesting to be used even for potable purposes. Oklahoma passed the Water for 2060 Act in 2012, to promote pilot projects for rainwater and greywater use among other water-saving techniques. In the United Kingdom, water butts are often found in domestic gardens and on allotments to collect rainwater, which is then used to water the garden. Industry. Frankfurt Airport has the biggest rainwater harvesting system in Germany. The system helps save approximately 1 million cubic meters of water per year. The cost of the system was 1.5 million decimeters (US $63,000) in 1993. The system collects water from roofs of the new terminal, which has an area of 26,800 square meters. The water is collected in the basement of the airport in 6 tanks with a storage capacity of 100 cubic meters. The water is mainly used for toilet flushing, watering plants, and cleaning the air conditioning system. Rainwater harvesting was adopted at the Velodrome, the London Olympic Park, in order to increase the sustainability of the facility. A 73% decrease in potable water demand by the park was estimated. Despite this, it was deemed that rainwater harvesting was a less efficient use of financial resources to increase sustainability than the park's blackwater recycling program. Quality. Rainwater may need to be analyzed properly, and used in a way appropriate to its safety. In the Gansu province, for example, solar water disinfection is used by boiling harvested rainwater in parabolic solar cookers before being used for drinking. These so-called appropriate technology methods provide low-cost disinfection options for treatment of stored rainwater for drinking. While rainwater itself is a clean source of water, often better than groundwater or water from rivers or lakes, the process of collection and storage often leaves the water polluted and non-potable. Rainwater harvested from roofs can contain human, animal and bird feces, mosses and lichens, wind-blown dust, particulates from urban pollution, pesticides, and inorganic ions from the sea Ca, Mg, Na, K, Cl, SO4, and dissolved gases CO2, NOx, SOx. High levels of pesticide have been found in rainwater in Europe, with the highest concentrations occurring in the first rain immediately after a dry spell. The concentration of these and other contaminants are reduced significantly by diverting the initial flow of runoff water to waste. Improved water quality can also be obtained by using a floating draw-off mechanism rather than from the base of the tank, and by using a series of tanks, withdraw from the last in series. Prefiltration is a common practice used in the industry to keep the system healthy and ensure that the water entering the tank is free of large sediments. Conceptually, a water supply system should match the quality of water with the end use. However, in most of the developed world, high-quality potable water is used for all end uses. This approach wastes money and energy and imposes unnecessary impacts to the environment. Supplying rainwater that has gone through preliminary filtration measures for non-potable water uses, such as toilet flushing, irrigation and laundry, may be a significant part of a sustainable water management strategy. See also: air well condenser, atmospheric water generator, deepwater rice, detention basin, peak water, retention basin, water conservation.